What if you could take a U.S. Department of Energy recommendation and realize wrench-ready payback in as little as 2 weeks? There are numerous belt-driven HVAC applications in a commercial building that contribute heavily to the overall consumption and electricity spend. By simply upgrading components, they can demonstrate dramatic results just as lighting projects have done. Lighting projects were initiated a decade ago because at the time, lighting was the largest consumer of electricity in a commercial building. Today, the largest consumer is HVAC equipment and the movement of air. Many facility managers and building owners have a number of options available to them to reduce their energy spend with belt-driven HVAC equipment. But one of the things they're challenged with is validating the energy savings up front in order to justify their project. With us today is Jesse Dupuy. And Jesse's going to walk us through the energy monitoring and validation process to help justify those energy projects.
Thanks, Don. So what we're demonstrating here is the effectiveness of different types of V-belts in their ability to transmit power from a motor to a fan in air handling applications. This is a 1 3/4 horsepower motor that we're using as a driver, and we're using the same size motor to simulate the loading conditions of a fan. And what we'll be comparing is the efficiency of wrapped belts as they compare to notch belts. Most commercial and industrial facilities use wrap belts, as the one seen here. These types of belts have a peak efficiency of 95%, but that's provided they're properly installed and maintained. However, most aren't, and you can end up seeing quite a reduction in the actual running efficiency. So to start off, I'm going to test the wrapped belt. We're going to install it properly to a predetermined tension that we're going to check on the load cell here and seen on the screen here. From the affinity laws, the CFM, or airflow, is directly proportionate to shaft speed. So what we'll be monitoring is shaft speed and using that to calculate an effective CFM. We'll also be monitoring the kilowatt consumption of the motor and belt temperature, and then we'll compare those values against what we get from the test of the notched belt. So what you can see here is the speed of the motor and the speed of the fan. The fan has a much lower RPM because the belt is slipping on the driven sheave. You can also see the kilowatt consumption of the motor. It's sitting at around 650 to 750 watts. We'll be running a 10-minute test and capturing the total energy used and the total airflow generated. Now we're going to install our notched belt. These belts have a peak efficiency of 98%. That 3% gain in efficiency will be seen in a reduction of the motor energy and an increase in the CFM produced. They run cooler, so they last longer, and they're much stronger, so that can give us an ability to optimize the design of a drive based on how much horsepower they can transmit. So again, what we're going to do is we're going to tension it to the proper tension as validated by our load cell and seen on our display. So what you can see right away is that the belt is much more stable and the driven speed is increased over what we were seeing with the wrapped belt. Now that our 10-minute tests for both belts have been completed, you'll see that the wrapped belts used more power and produced less CFM as compared with the notched belts. So you've just seen a test done in a lab environment. And now what we're going to do is we're going to talk about the process of doing energy validation at a customer's facility. Now let's take a quick look at the field diagnostic equipment we have available for being able to monitor the energy consumption at the customer's facility. We have the power meter. That allows us to monitor the kilowatt consumption of the motor. We have rotational speed sensors. That allows us to monitor both the driven and the driver shaft speed. We have temperature transducers. That allows us to monitor both the internal and external temperatures. We have pressure transducers. That allows us to monitor the differential pressure so that we can calculate the CFM output of the fan. And from there, we can take all this data and wirelessly transmit it through an independent network to the Power Transmission Solutions engineers for analysis. So essentially what we're going to do is we're going to create a baseline of the energy usage and the airflow performance. We're then going to perform a Browning optimization of the drive and install the new high-performance components. We'll then do a post-analysis, where we can take that data and we can generate a report that gives you your return on investment and your payback period. Now we can do all that turnkey, or if you prefer, we can lease or sell you the equipment. So if you're looking for your next low-hanging fruit project with a solid payback period and a high ROI, Browning have the products and services available to help you with your energy validation.
Whether it's reducing your energy footprint or getting the justification you need for an incentive or rebate, we've got you covered. Contact your Browning representative for more information.